Hello friends, welcome to Electrical Design Engineering YouTube channel. Today is our lecture number 17. Actually, I was going to put a lecture on the short circuit analysis today, but various subscribers have asked about the OLTC, that is on-load tape changer, how we can set it in the Etap. So I decided to put a lecture on the OLTC, on-load tape changer. Let us start the lecture. Before starting the lecture, please subscribe the channel, like and share the video on your social media profiles. OLTC, on-load tape changer, is an important component used in transformers to regulate the output voltage by changing the transformer winding taps while the transformer is still energized and on load. This capability allows for continuous voltage regulation without interrupting the power supply, making it particularly useful in electrical power system where the maintaining a stable voltage is critical. I will show the diagram of OLTC. This is the OLTC diagram. These are the tappings. With the help of these tappings, we can change the number of turns on the primary side. I am saying here primary side and secondary side. You mean that primary side is the higher voltage side and secondary side is the lower voltage side. I have considered here the distribution transformer, that is step down transformer, which steps down the voltage from higher voltage to lower voltage. Primary winding has considered higher voltage side here, and secondary winding has considered here lower voltage side. I mean that OLTC is always provided on the higher voltage side. That is why I have shown here the OLTC is shown on primary side. Why the transformers have OLTC on higher voltage side or primary side? There is some reasons of that. I will show why is provided on the primary side or higher voltage side. I have never seen that the OLTC has provided on the lower voltage side. This is the core of the transformer. If you have worked on the transformer manufacturing factory, you can see this is the type of cores in the transformer is used. This is the internal structure of the core. You can see the higher voltage side. I will show you. The higher voltage winding is outside of this side, and the lower voltage side is inside of the higher voltage side, higher voltage winding. That means on the core, lower voltage winding is provided, then higher voltage winding is provided. That means higher voltage winding is covering the lower voltage winding. So it is easy to take tappings from the higher voltage side than take it from the lower voltage side. Lower voltage side or a lower voltage winding. You understand here? Now, second reason is that suppose we have a transformer 100 kVA 11 by 0.41 kV. This is a distribution transformer used in India. Primary current is 5.25 amperes and the secondary current will be 139 amperes. Here you can observe one thing. The secondary current is higher than the primary current. What will happen? The current on the higher voltage side of a transformer is lower compared to the lower voltage side for the same power level. During the switching process, an OLTC may produce electric arcs, especially under load. Lower currents on the higher voltage side means that arcs are less intense, which helps in reducing the risk of damage to the tape changer contacts and prolongs the lifespan of the OLTC. That means on the primary side, the current is low. With the low current, the arcing will be less. The arcing will be not such intense as compared to the secondary side, because the current on the secondary side is on a lower voltage side is very high, and the arcing will be there very high. Due to low intensity of electric arcs, less helps in reducing the damage to the contactors of the OLTC and other things, and increase their lifespan. It is easy to control a low voltage current than to control a high voltage, high current, high ampere current. That is the reason. Second reason why OLTC is provided on higher voltage side than in the lower voltage side. How tap changing changes the output voltage output. Now we have to see with the help of tapping this how we can change the output voltage. We know Vp by Vs is equal to Np by Ns. Np is the number of turns on primary side. Ns means the number of turns on secondary side. Vp means the voltage on primary side, and Vs means the voltage on secondary side. Vs is equal to Ns divided by Np into Vp. Here the Vs is inversely proportional to the primary number of turns on the primary side. With the help of tapping this, I have shown the previous figure. You can see here this figure. With the help of a number of tappings, if you put this position at here, the number of turns on the primary side will increase, and here it will decrease, and here it will decrease, and here it will decrease. With the help of changing the number of turns on the primary side, we can change the output voltage. Okay, this is the nameplate of one of the ABB transformer. You can see on tappings there are 5 taps on the primary side and on high voltage side, and each step is 2.5% of the voltage of the primary 11 kV high voltage side. Now I can use same nameplate in the Etap, and you will see how voltage is controlled. Okay. Now this is the simple diagram. I have made a very simple diagram to understand you what OLTC does, how OLTC is helping to maintain the output voltage. This is a power grid, and this is a distribution transformer 100 by 100 kVA, and this is a simple cable, and this is the load. You can see one thing here. First of all, I will show in tapping. When we double click the transformer, and we will enter the transformer winding editor, and here is the tap. And you can see I have not selected the tapping. First of all, I have not selected any tap. I click OK, then perform the load flow analysis. Okay, I will perform the load flow analysis and see what is the results are coming. You can see the here the voltage is 100% and the here voltage is 92.23%. Almost 8% of voltage drop is here. So it is not acceptable. There is also an alert. You can show here here there is an alert. We can see what is the alert. Bus 3 is under voltage. That means this percentage of voltage drop is not acceptable. 8% voltage drop is not acceptable. It is considered an under voltage bus. Now, how we can change this thing? One thing is that we can increase the transformer capacity, and another thing we can use the OLTC. With this help, we can change this. We can make this alert to clear. So we can double click on the transformer and enter the transformer editor and go to the tappings. Here it is OLTC. You can take the AVR, that's automatic voltage regulator, and then double and click on the LTC. Here LTC have in the diagram, in the nameplate, we have maximum of -5%, and maximum of 5%, and minimum -5%, and steps are 2.5, and you can see there are showing 5 taps. Same in the nameplate, you can see in the right side of this diagram, the same 5 steps are here. Now we can change this. It will be 1.25 and 1.25. This is how we can know what is the values of upper band and lower band. This is 2.5, can divide by 2, and upper band will be 1.25 and lower band will be 1.25. The sum of these 2 bands, and the sum of these 2 will be 2.5. Okay, now we can OK and tick OK. Now we can perform a load flow analysis. Now you can see first it was 92 point something, now it is 97.33. Where I have forgot to one thing to say you that Etap and go to OLTC, you can select here which bus you want to control, voltage of which bus you want to control. You can select bus 1, bus 2, bus 3. Here we are using the bus 3 to control the voltage because it is connected with the load. It is a load bus. Okay, you can check here. Okay, now you have understand how it can go. You can also display here the tappings of the transformer. I can go display and AC. I will take it is okay. But here the tappings are not shown. So we can go to the here load flow and take the transformer LTC and click OK. And perform the load flow analysis again. Now it is showing minus 5% tapping. That is on minus 5% of the tapping. Tapping is minus 5%. It is the upper band, lower band. Okay. Thank you. If you have any questions, you can ask me and I will answer.